Hello my dear students, welcome to my YouTube channel that's Concepts of Chemistry. Before starting today's lecture, please do subscribe my channel. My dear students, today's topic for the lecture is the lattice energy. In the previous lecture, we have studied about the formation of the ionic bond. We all know that infinite number of cation combines with infinite number of anions through ionic bond to give rise to a macromolecule called lattice, and the energy released during the formation of 1 mole of lattice is called lattice energy. Let me write this thing for you. When infinite number of cations and anions combines through ionic bond, giving rise to a macromolecule called lattice. Next, the energy released. The energy released during the formation of 1 mole of lattice, during the formation of 1 mole of lattice from its constituent ions is called lattice energy. Now let's talk about sodium chloride as an example. Sodium chloride. We all know the molecular formula or the formula unit of the sodium chloride. It's NaCl. The NaCl is formed by the combination of sodium ion and the chloride ion. Now, for the formation of 1 mole of NaCl lattice, we need 1 mole of Na positive ions and the 1 mole of Cl negative ions according to this equation. So, energy released for the formation of 1 mole of NaCl lattice is called lattice energy. So, in the formation of 1 mole of lattice, 1 mole of Na positive ions are required and the 1 mole of Cl negative ions are required. In terms of number, the 1 mole of Na positive means 6.022 into 10 to the power 23 Na positive ions. And in terms of chloride ion, the 1 mole of chloride ion means 6.022 into 10 to the power 23 chloride ions. When this much number of sodium ions and the chloride ions combines through the ionic bond give rise to the 1 mole of lattice of NaCl, and the energy released during this process of formation of 1 mole of lattice of NaCl is called lattice energy. Now, I am going to draw the lattice of NaCl. The lattice of NaCl is cubical and I am drawing the smallest, simpler repeating unit cell of the sodium chloride. The smallest repeating unit in the lattice of sodium chloride I am going to draw. Here, I have drawn a cube already. In this cube, I am going to mark chloride ion with this yellow circle. This is the chloride ion. So where is the chloride ion is present? at the corners of this cube, the chloride ions are present. So I am marking the first position. Cl negative ions are present at the corners of the cube. Now let's talk about the Na positive ions. Here I am writing Na positive ions. I am marking with the green color. So where are the Na positive ions present? At the firstly, Na positive ions are present at the center of the each edge. This is the first center of the edge. We are having total of 12 edges. The second edge, the center of second edge, the center of third edge, the center of fourth edge. Now the center of the fifth edge, the center of the sixth edge, the center of the seventh edge, and here's the center of the eighth edge. Now the center of the ninth edge, the center of the 10th edge, here's the center of the 11th edge, and here's the center of the 12th edge. Now let me join all the edges. Just an imaginary linkage, it's not the real one which I'm going to draw with the green. Just pay attention. It is just the first imaginary linkage. The second one, the third one, and here is the fourth one. Now the green one is just an imaginary linkage, just to make you clear the things. Sixth one, yeah, just like this. Now is this one, this one, is this one, and this one. So it's all about the Na positive ions, and I have marked all the Na positive at the center of all the 12 edges. Now let's come back to again chloride ions. We are having more number of chloride ions. Let me write this thing first. Sodium ions, the very first position of sodium ions. Na positive ions are present at the centers of the edges of the cube. Now, let's come back to the chloride ion. The second point. The chloride ions are also present at the face centers of all 6 faces of the cube. So where are the more Cl negative ions are present? So let's talk about the first of all the face centers. This comes out to be the first face center, the second face center, the third face center, the fourth face center, the fifth face center, and the sixth face center. Now let me combine all this. So that's it. Now I'm left with one Na positive, and which is present at the exact body center of this cube. The second position of Na positive ion is at the body center of the cube. So this is the simplest and the smallest arrangement of Na positive ions and the Cl negative ions in the 3 dimensions. Here you can imagine that the sodium and chloride ions are present at alternate positions in 3 dimensions. Whether you take the x-axis or the y-axis or the z-axis, you can easily find that chloride ion and the sodium ion are present at the alternate positions. When Avogadro number of sodium ions and the Avogadro number of chloride ions arrange themselves in alternate fashion in 3 dimensions will give rise to the 1 mole of lattice, and the energy released during the formation of 1 mole of lattice is called the lattice energy. So that's all about the lattice of the NaCl. Now let's talk about the factor on which the lattice energy depends. First of all, let's apply Coulomb's law over here. Coulomb's law. Coulomb's law tells about the force of attraction or repulsions between the two charges. The Coulomb's law states that the force of attraction or repulsion is directly proportional to the product of magnitude of the two charges, and it is inversely proportional to the square of distance between them. Now let's combine both these terms. F directly proportional to the Q1 into Q2 divided by R square. Here F comes out to be the proportionality constant is 1 upon 4 pi epsilon naught into Q1 into Q2 by R square. Now here the Q1 is the charge of Na positive ion and Q2 is the charge of Cl negative ion. And what's R? It's the internuclear distance between two ions. That is, small r is equal to the radius of Na positive ions plus radius of Cl negative ions. Now from this formula, here we can easily predict that lattice energy What is lattice energy? It is the energy released during the formation of 1 mole of lattice. So it's a combination or it's a formation of ionic bond between the two ions. The two oppositely charged ions is the force of attractions. So lattice energy will be inversely proportional to the sum of radius of Na positive ion and the radius of Cl negative ion. So we can say that lattice energy is inversely proportional to the radius of cation and the radius of an ion. The lattice energy is inversely proportional to the sum of radius of cation and the radius of an ion. As more the force of attraction, more will be the lattice energy. Hence, lattice energy will inversely depend upon the sum of the radius of cation and the radius of an ion. What next? In simple terms, we can say that lattice energy during the formation of any lattice, the lattice energy is directly proportional to the charge densities of the combining ions. Charge densities of combining ions. Now let's talk about charge density. First of all, charge density is represented by a symbol phi. It's phi. Now the charge density that is phi is equal to the magnitude of charge divided by radius of that ion. Let me take an example. Let's talk about the question is compare lattice energy of NaCl and KCl. Which one will have the higher lattice energy? NaCl, KCl. Here what we are having common? The chloride ion. Then just forget about it. Let's talk about the Na positive ion and the K positive ion. As we all know, the sodium and potassium belongs to the group number 1 and potassium is below the sodium. So the radius of potassium ion will be greater than that of the radius of sodium ion. Now, charge density. Charge density is charge divided by radius. That means this charge density is inversely proportional to the radius of the ion, which means the charge density of Na positive will be greater than that of charge density of the K positive, because the radius of K positive is greater, so its charge density will be lower. I am writing the radius of K positive is greater, so the charge density of K positive will be lower. On the other hand, the radius of Na positive is lower than that of the K positive, so the charge density of Na positive will be greater, due to which we can say that NaCl has more lattice energy than KCl. Now let's talk about the next fundas which are related to the lattice energy. Higher the lattice energy, stronger will be the lattice. So higher the lattice energy, stronger will be the lattice, lesser will be its solubility. It signifies that the lattice of NaCl, the lattice of NaCl is stronger than KCl. Now, in the above example, we have taken the radius of anion to be constant, as we have taken both the chloride ions. Now, let's take the constant value of cation. Let's take another example. I am writing compare lattice strength of NaCl and NaBr. Here I have taken the constant value of radius of cation and I have changed the anion. Now, in case of both these, NaCl, NaBr, focus on the radius of chloride ion and that of the bromide ion. The radius of bromide ion is greater than that of chloride ion because both are the members of the halogens and bromine lies below the chlorine. So the radius of bromine or bromide ion will be greater than that of the chloride ion. So due to which what will happen? Lattice energy of NaCl. Sorry, first of all, let's talk about the charge density. Due to which the charge density of chloride ion, will be greater than that of the bromide ion. It signifies that lattice of NaCl is stronger than lattice of NaBr because lattice energy of NaCl is greater than NaBr. As the lattice energy of NaCl is greater than the NaBr, so the lattice of NaCl will be stronger than that of the NaBr. Because in the case of NaCl and Br, the radius of chloride ion is smaller than that of the radius of bromide ion, due to which the charge density of chloride ion is greater than that of the bromide ion, which signifies that lattice energy of NaCl will be greater than that of the NaBr. So the lattice of NaCl will be more stronger than the lattice of NaBr. So that means, let's talk about the general trend of the periodic table. I'm writing down the group, size increases, or we can say radius increases, which signifies charge density will decrease down the group. Charge density will decrease down the group, which further signifies that lattice energy will also decrease down the group in case of any group. So in case of any group, as we move down the group, lattice energy will decrease and hence the lattice will become weaker and weaker as we move down the group. And in case of period, as we move across the period, the magnitude of charge increase and radius decrease, which further signifies that charge density, the charge density will increase across the period, and hence lattice energy will also increase across the period. Let me take an example of two lattices across a period. Let's talk about NaCl and the MgCl2. First of all, it's Na positive and it's Mg2 positive. We are ignoring chloride ions because common in both the cases. Let's talk about the cations. That's the Na positive and Mg2 positive. So here the charge density will be 1 positive divided by radius of Na positive, and here the charge density will be the 2 positive. The magnitude of charge is 2 divided by radius of Mg2 positive. Now, as we all know, the radius of Mg2 positive is smaller than that of the radius of Na positive because we are moving across a period, sodium and then magnesium. The magnesium comes after sodium in a period number 3. So that means the charge density of Mg2 positive will be much greater than the charge density of Na plus 1, which signifies that lattice energy of MgCl2 will be much greater than the lattice energy of NaCl. That means MgCl2 has a stronger lattice than NaCl. So that's all about. Let me recapitulate one thing, and a very important thing, that lattice energy is inversely proportional to the sum of the radius of cation and that of the radius of anion, which we are going to compare with the hydration energy in the next lecture videos. So that's an important thing, and it's all about today's lecture. That's all. I hope you all understood today's lecture. If any student wants to book a paid one-to-one class, if any student wants to book a paid one-to-one online class to clear their doubts, then she can contact me. My phone number is mentioned on thumbnail of this lecture. Please do like, subscribe and share this channel to maximum number of students. Don't forget to press the subscribe button. Stay blessed.